Sometimes one would like to combine the results of two or more comparisons. For example, in the MPG dataset, one might want to know if there are any pickup trucks with more highway mileage than 20 miles per gallon. To do this, we would perform two comparisons. Which trucks have the class variable with value pickup, and two, which trucks have highway variable greater than 20. Then we would combine the results of the two comparisons in order to determine the trucks for which both conditions are met. These kind of combinations of comparisons can be performed with what are known as Boolean or logical operators. For example, there is a logical operator called and if I take two Boolean values and combine them with the AND operator, what it returns is true only if both the Boolean values or Boolean variables are true. So for example, if I combine false Boolean value with false and run the code chunk, I get false. And of course, ampersand is the Boolean operator for the AND operation. And if I did true and false, it still returns false. And the AND operator will return true in one and only one condition when both the inputs, the variables or values, are true. And now when I run the code chunk, it returns true. One can check what the Boolean operators are by looking up the help on logic. And if you click on logical operators, it shows all the different logic operators that there are. There is exclamation X, and this is known as the not operator. It is a negation operation. If X is true, then not X is false. And if X is false, not X is true. As we have already discussed, you have AND operation, which returns true only if both the inputs are true. You have the OR operation, which returns true if one or more of the inputs are true. And lastly, there's the exclusive OR or XOR operation. The Boolean operators don't just work between scalar values, but also work between vectors and scalars, vectors and vectors, or data frames, and so on. Let's test this out by creating what's known as a truth table for the logical AND operation. And what we'll do is we'll create two logic vectors that encapsulate all the possible combinations of two logical values. So we can have true, true, false, false, and in 2, which is the second input, could be true, false, true, false, and therefore together in 1 and in 2 encapsulate all the possible combinations. You have true, 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 false, false, true, and false, false. And now let's make a data frame. Let's call it truth table and we'll use the data.frame function, and in data.frame the arguments are the columns, and the name on the left hand side of the equal sign is the name of the column, while on the right hand side are the values that will go in the column. So we will say in1 is the column name, and in1 is the logical vector that specifies the values in the column. Same for in2. And then we will add a third column, which is determined by the logical AND between in1 and in2. And when you have a logical AND between two logical vectors, it basically goes element wise, and the first element of out is going to be given by AND between the first elements of in1 and in2. The second element of out is going to be given by logical AND between the second elements of in1 and in2, and so on. And this will create the data frame, and then we can just print out this data frame. So when I run this code chunk, now I see a data frame in which each row is one combination of inputs: true, 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 false, false, true, and false, false. And the last column, the out column, tells us what the output of the Boolean AND operator is. And as I stated previously, there's only one condition in which we get true. That is when both the inputs are true. Now we could copy this code and try and create a truth table for the logical OR operation. And all we need to do is change the name of our truth table, and instead of the logical AND operation, we will use the logical OR operation. And when we run this code chunk, this data frame represents the truth table for the OR operation, and you can see that the OR operation is the opposite or the negation of the AND operation, so that it is false only in one condition, when both inputs are false, and it's true if one or more input is true. So now let's use these Boolean operators to try and answer the kind of question that I posed at the start of this video. We would like to know how many, in the MPG dataset, how many pickup trucks have highway mileage greater than 20 miles per gallon. And I'm going to insert a code chunk, and the first thing to do is to use the relational operators, the comparison operators, to construct the Boolean logical vectors. So first is pickups. Let's say pickups will be a logical vector representing all the vehicles for which class is equal to pickup. And so we will say MPG, let's pick the class column, and now we want to say class is equal to, so we have to use the equality relational operator, is equal to pickup. And keep in mind once again that this is literal string. It's not a variable known as pickup. It's actually data or literal string that is pickup, so we have to enclose it in quotes. And let's say we want highway greater than 20 to represent all the vehicles for which the highway variable has a value greater than 20. So you pick the highway column greater than 20. So this is no different than what we had done previously, where we have used the relational operators to construct logical vectors for which certain conditions are true. But what's new now is we're not just interested in pickup trucks or vehicles having highway mileage greater than 20. We are interested in the vehicles for which both conditions are true, and therefore we can use the AND operation to construct a new logical vector called pickup and greater to identify those vehicles which are pickup trucks and have highway mileage greater than 20. So I'll say pickups, use the ampersand or AND logic operator, highway greater 20, and then we can just pick up, print out the value of this, and you will see that it's mostly false and it's going to be very hard to count this. So we can use our sum trick, which the sum function sums all the values of its inputs. In this case, trues are 1, falses are 0. And so if I sum these values, the answer would equal the number of vehicles for which this logical vector is true, which means the number of vehicles that are pickups and have highway mileage greater than 20. And when I run this, the answer is 1. So it turns out in this large data set, there's only one pickup truck which has highway mileage greater than 20 miles per gallon.